Here's an example in which we're finding a vector with magnitude 9 points in the direction 100 degrees counterclockwise from the positive x-axis. So I'm going to actually draw this vector. Okay, and so 100 degrees be about like that or so. So the vector is like that. The vector is magnitude 9, its length is 9, and it's like this, 100 degrees from the 0 degree positive x-axis, right? So you don't need to write 0, but it's 100 degrees counterclockwise from the positive x-axis. This is the positive x-axis. So, and its length is 9, magnitude 9. So the question is, write the vector. What they want us to do now is write the vector in component form, meaning like the x component and the y component with the braces around it. So how do we do that? How do you change it? Well, basically, what you're going to do is remember that whenever we have an A, let me just show you right over here. Remember that, that's not very well done. Let me try again. Remember that whenever you have an angle and you have a vector like that, that we want this distance, this is the x and this is the y that we're looking for in the vector, right? At some angle theta, and let's call it magnitude m. That's the length of the vector. Remember from SOHCAHTOA, that the sine of theta is opposite over hypotenuse, y over m. And the cosine of theta is adjacent over hypotenuse. Right? So SOHCAHTOA, cosine is adjacent over hypotenuse, sine is opposite over hypotenuse in a right triangle, and a vector. When we talk about the x and the y components, they go sideways, x goes sideways and y goes straight up and down, so that makes a right triangle. So therefore y, if you multiply the m over, is m sine theta, and x is m cosine theta. I'm not writing that very neatly. Let me just try to do it the other way. So y is m sine theta, and x is m cosine theta. Right, see what I did there? I just multiplied both sides by m here. Cancel that out. And the same thing here, multiplied both sides by m, cancel that out. So there we go. So there's the formula. Y is m sine theta, x is m cos theta. So if we want to find the x component, its magnitude cosine theta. So what's the magnitude? 9 times the cosine of 100 degrees. Use your calculator. Make sure you're in degree mode. This is a degree. Angle minus 1 point, and they want 1 decimal place, minus 1.6, and y is m sine theta, which is 9 sine of 100 degrees. Use your calculator for that one as well. I'm getting 8.9, it rounds to. So there it is. So the vector in component form is the x first minus 1.6 for the x, 8.9 for the y. Oops, I didn't make that too neat. This is the x, this is the y, so it's back a little bit, up a lot, back 1.6, up 8.9, the x and the y. And it makes sense, doesn't it? Because you want to memorize this formula for the long haul, that x is m cos theta and y is m sine theta. Remember, whenever we did the unit circle, the x coordinate was always cosine and the y was always sine. So x is always cosine, so it makes sense that x goes with cosine, and y was always sine, so it makes sense that y goes with sine. So x is m cosine theta, y is m sine theta, comes over here from the SOHCAHTOA, the fact that a vector is part of a right triangle. So there we go. Whenever they want us to find the components, for the x, we just go m cosine theta, magnitude times cosine theta, and for y, magnitude times sine theta.